All right, this weekend's lessons on proving angles congruent. It's the last section of chapter 2. We're going to actually start using some theorems, and then once we come up with a theorem, we have to prove that theorem to be true before we can use it in the future for other proofs that we do. We're going to begin with a review like we always do. Today we're going to complete each sentence with the words proof or prove. Galileo wanted to blank that the planets revolve around the sun. He wanted to prove that the planets revolve around the sun. His observations and discoveries supported his theory, but were not a proof of it. He was not able to prove it in his lifetime, so it wasn't a proof of his theories. Our word for this weekend's lesson is theorem. A theorem is a conjecture or a statement that you prove true. Once you have used that theorem and proved it to be true, you can use it to prove other theorems in the future. So once a theorem is proven true, you can use it to prove theorems that follow. So we're going to write true or false, true for T for true, F for false. A postulate is a theorem. That is false. A postulate is a true statement that is a given fact and a known fact. A theorem may contain definitions. That is true. A theorem may be actually made up of definitions. An axiom is a theorem. Again, that's false. An axiom is more like a postulate. It is a property or a rule. So we're going to complete each sentence statement with the words lines, planes, or points. These are the first four postulates that we learn. Through any two blank, there is exactly one line. You should remember that from your test. Through any 2 points, there is exactly one line. Postulate 1, 2. If two distinct lines intersect, then they intersect in exactly 1 point. Similarly, postulate 1, 3. If two distinct planes intersect, then they intersect in exactly one line. And finally, postulate 1-4. Through any 3 non-collinear points, there is exactly one plane. All right, we're going to start our lesson today with theorem 2-1, the vertical angles theorem. That theorem is simple. Vertical angles are congruent. Simple statement, it is what it is. If angle A and angle B are vertical angles and the measure of angle A is 15, then the measure of angle B is 15. So how would we use the vertical angles theorem? We use it to solve problems. In the drawing we have on the right, we have one angle is equal to 3x degrees and the other angle is equal to 2x plus 40 degrees. We're going to circle the word that best describes the label angle pair in the diagram. You try to say that fast. Circle the word that best describes the labeled angle pair in the diagram. They are vertical angles. Circle the word that best describes the relationship between the labeled angles in the diagram. Well, vertical angles are congruent. So we're going to use the labels in the diagram to write an equation. 3x equals 2x plus 40. So we'll rewrite that equation, and now we're going to solve it. First, we'll just subtract 2x from both sides, and once we solve that, we quickly see that x equals 40, so the value of x is 40. So that's how you use the vertical angles theorem to solve problems with vertical angles. The next thing we're going to look at is a proof using the vertical angles theorem. We're going to use the vertical angles theorem to prove the following. We are given that angle 1 is congruent to angle 2, and we want to prove that angle 1 is congruent to angle 2, which is congruent to angle 3, and is congruent to angle 4. So first we start off, as I said, in any proof, usually the given statement is the first step. So angle 1 is congruent to angle 2 is given. The second step, angle 1 is congruent to angle 3, is because vertical angles are congruent. Angle 1 and angle 3 are vertical angles. Angle 2 is congruent to angle 4 because vertical angles are congruent. And finally, angle 1 is congruent to angle 2, which is congruent to angle 3, which is congruent to angle 4, is just a really big use of the transitive property of congruence. So that's how we solve problem 2. Let's look at another theorem. Theorem 2-2 is the congruent supplements theorem. If two angles are supplements of the same angle or of congruent angles, then the two angles are congruent. If angle 1 and angle 3 are supplements, and angle 2 and angle 3 are supplements, then angle 1 is congruent to angle 2. So let's look at the diagram below. We're going to label the first angle, angle 1, and it's a supplement with angle 3. And then our last angle, which is congruent to angle 1, is angle 2. Problem 18. If measure of angle D equals 135 and the measure of angle G equals 45, and angle F and angle G are supplements, then the measure of angle F is 135. What did I do there? Oh, F and G are supplements. That means they have they too are equal to 180. My apologies. It's Friday afternoon. That's what happens. Angle F and angle G are supplements, so 45 plus 135 equals 180. So the measure of angle F is 135. If angle A and angle B are supplements, and the measure of angle C is 85, and the measure of angle B is 95, then the measure of angle A is 85. So together, if two angles are supplement to the same angle, then those angles are congruent. So let's write a paragraph proof. I'm not a big fan of paragraph proofs. I prefer two-column proofs, but we're going to write a paragraph proof for the vertical angles theorem. So given that angle 1 and angle 3 are vertical angles, we're going to prove that angle 1 is congruent to angle 3. And a paragraph proof is just what it says. It's a paragraph. You state what's given and you get to the point to what you're trying to prove. So angle 1 and angle 3 are vertical angles because that's what is given. Angle 1 and angle 2 are supplementary angles because they form a linear pair. Likewise, angle 2 and angle 3 are supplementary angles because they form a linear pair. The measure of angle 1 plus the measure of angle 2 equals 180 because the sum of the measures of supplementary angles is 180. The measure of angle 2 plus the measure of angle 3 equals 180 because the sum of the measure of supplementary angles is 180. By the transitive property, we can say the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. By the subtraction property, we just subtract the measure of angle 2 from both sides. We get that the measure of angle 1 equals the measure of angle 3. Finally, and in conclusion, angles with the same measure are congruent. So angle 1 is congruent to angle 3. Now you would have to write all that out in a nice paragraph form when writing a paragraph proof. That's why me as a math person, I like two-column proofs more so than paragraph proofs. Now let's look at a couple more theorems. Theorem 2-3 is the congruent complements theorem. If two angles are complement of the same angle or of congruent angles, then the two angles are congruent. This is similar to the supplement theorem, but now it's the complement theorem. Angle A is a supplement of a 165-degree angle. Angle B is a complement of a 75-degree angle. Circle the relationship between angle A and angle B. Both angles are 25 degrees, therefore they are congruent angles. Theorem 2-4 basically just states all right angles are congruent. All right angles equal 90 degrees, so they all have the same measure. Theorem 2-5 states if two angles are congruent and supplementary, then each is a right angle. If angle R and angle S are right angles, then the measure of angle R is congruent to angle S. And then finally, if angle H is congruent to angle J, and angle H and angle J are supplements, then the measure of angle H equals the measure of angle J, which equals 90 degrees. So those are the theorems that we're going to go over in this section of chapter 2, and we will work on those on Tuesday on proving them. So let's go quickly check our lesson as we finish up. What are the measures of angle 1, angle 2, and angle 3? So we're going to cross out the theorem that we cannot use to find the angle measures. We could use the congruent complements theorem because angle 1 and 3 are opposite, are together are complementary angles. We would not use the congruent supplements theorem because there aren't just two angles that form a supplementary angle, there are three angles. And we would use the vertical angles theorem because that's how we're going to figure out our measures. So we'll cross out the congruent supplements theorem. The measure of angle 1 is opposite or a vertical angle of a right angle, therefore its measure is 90 degrees. The measure of angle 2 is a vertical angle with an angle that measures 50 degrees, so its measure is also 50 degrees. And finally, the measure of angle 3 is opposite the angle that measures 40. In addition, it forms a complementary angle with angle 2, so its measure is 40 degrees. Our final lesson check for this lesson is if angle A and angle B are supplements and angle A and angle C are supplements, what can you conclude about angle B and angle C? Since angle A and angle B are supplements, their measure together equals 180. Since angle A and angle C are supplements, their measure together also equals 180. We can use the transitive property to equality to say that the measure of angle A plus the measure of angle B equals the measure of angle A plus the measure of angle C. By the subtraction property, subtracting the measure of angle A from both sides, we know that the measure of angle B is equal to the measure of angle C, so angle B is congruent to angle C. I noticed a lot of theorems that were throwing out there all at once, and they waited until the end of the chapter to go over them. We've already proven the vertical angles theorem. We did that in our paragraph proof, but we'll work on proving the other theorems in class on Tuesday. If you have any questions, please write down your questions and we'll go over them. I hope you enjoy your weekend off and your extra day off celebrating the president's birthday while I work. But hey, that's good for you to have time off while I work. Have a good evening, good night, or a good day, no matter, depending on when you watch this. See you on Tuesday.